So hi one and all. In this video, I'm going to explain experiment number 1 which will falls under part A. As we all know that the experiments which comes under part A are hardware experiments, and since they are hardware experiments, those experiments has to be carried out using hardware devices like trainer kit, ICs, connecting wires and so on. I hope you people have watched previous class videos to know about hardware devices, as I said, like about trainer kit, connecting wires, ICs, etc. and so on, right? So in this video, the objective is to explain how to design a circuit for full ladder, and in the coming class videos you will see how whether the design circuit will perform the operation of full ladder, right? Okay, as I said, what is the aim of this experiment is we need to design a circuit called full ladder, correct? We need to design a circuit called full ladder using basic gates, or make it simple using logic gates. Clear? Using logic gates. Once again I will repeat, the aim is to design a circuit for full ladder using logic gates. Examples for logic gates are AND, OR, XOR, right, NOT, etc. and so on. So the first step in designing a circuit for full ladder or any other circuit for that matter is to understand the concept at a high level. Let us assume a full ladder is basically a circuit. Let us assume that full ladder is basically a circuit or electronic device which will take three inputs, okay, and it will produce us two outputs. So these are inputs, and these are outputs, right? And we shall call inputs as X, Y and Z, output as sum. So instead of writing sum completely, I am using S, and carry out. Instead of writing carry, I am writing C, right? So now this is the first step. What you have to do is understand the concept at a high level. So basically what you have to do here it is, you need to come up with a circuit which looks like this, means which should take three inputs. So we, in this case, we have labeled the inputs as X, Y and Z. There is no rule that you should use X, Y, Z only. You can use instead of X, Y, Z, you can use A, B, C, P, Q, R, etc. and so on, and it will produce us two outputs. One is sum and the other one is carry. So at a high level you can understand this. Basically this is basically an adder circuit which will perform addition operation. Clear? So this is what you need to do at a high level. Okay, so at a high level basically you need to design an adder. Clear? Okay, now we shall go to the second step, or we shall go one level below. What we have to do is we need to design the circuit using logic gates like AND, XOR, NOT, etc. and so on. Here now we shall see how to do this. So the second important step for this to do this is we need to understand the operation of this circuit with the help of a truth table. So as we all know that truth table will have two sections. One is input section and the other one is output section, right? Output section. So we shall have a line over here. Okay, we shall segregate input and output section. Okay, look at the block diagram or a high level diagram. How many inputs this full ladder circuit will take? Three inputs. Which are those? X, Y and Z, right? And how many outputs it will produce us? Two outputs. One is sum and the other one is carry, right? Correct? So how many number of rows will be there in this truth table? It will be 8, right? It will be 8. How it is 8? So we already know that in the previous classes. So the number of rows in the truth table depends on how many number of inputs that the circuit will take, right? So in this case the circuit will take three inputs, 1, 2 and 3. Hence we have to replace n by 3, which is nothing but 8, right? So 8 number of rows will be there in this truth table. Now let us go we shall write all the 8 combination. So the first combination is X is 0, Y is 0, Z is 0. Second combination is X is 0, Y is 0, 1. Similarly 0, 1, 0, then 0, 1, 1, then 1, 0, 0, then 1, 0, 1, then 1, 1, 0, then 1, 1, 1, and verify whether we have written all the 8 combinations: 1, 2, 3, 4, 5, 6, 7 and 8, right? Okay. Now we shall understand how to write values for sum as well as for carry. It is very simple. Just observe over here. So as I said, what actually adder will do? Addition operation, right? Okay. How it will do? Bit by bit. So 0, first it will add these 2 bits, x plus y. 0 plus 0 is what? 0. I am writing intermediate result with the blue color, 0. Plus again it will perform addition operation on this 0 and this 0. So in this case, sum will be 0, carry will also be 0. Similarly, 0 plus 0 is what? 0, right? Again 0 plus 1 is what? Sum will be 1, carry will be 0. 0 plus 1 is what? 1, right? 1 plus 0 is what? Sum will be 1, carry generated will be 0. Okay, now 0 plus 1 is what? Sum will be 1. 1 plus 1, this is important. 1 plus 1 is, sum is 0, carry generated will be 1, right? Again 1 plus 1, 0 is what? 0. Sorry, 1 plus 0 is what? 1. 1 plus 0 is 1, carry generated will be 0. 1 plus 0 is what? 1. 1 plus 1 is, 1 plus 1 is, sum will be 0, carry generated will be 1. Again 1 plus 1 is what? 0, and carry generated will be 1. 0 plus 0 is what? 0, right? 1 plus 1 is what? 0, right? 0, carry generated will be 1. 0 plus 1 is what? 1, right? So this is how you need to write the truth table for sum and, or generally called for full adder. Okay, for sum and carry specifically. Clear? Okay, if you go wrong here, then the next steps will go wrong. Okay, so this is very important. I hope you understood how to come up with a column for sum and for carry, right? And the next step is you need to represent this sum and carry in Boolean expressions. And we know that Boolean expressions can be written in two forms. One is min term, okay, and the other one is max term. Min term, max term. So we shall use min term for writing Boolean expressions in the laboratory, but anyhow you will learn both min term and max term representation in theory classes. Clear? The another name for this are SOP and POS. I think you people have heard these words in theory classes. Clear? Now we shall represent the Boolean expression for sum and carry in min term form. Okay. Okay, but if you learn one way, the other way is exactly the opposite of the first one. Clear? So my suggestion is just follow the one way. Obviously, if you follow the one way thoroughly, you can easily switch on to the alternative way. Clear? Okay, now we shall go one by one. As I said, we need to write a Boolean expression for sum and then carry. We shall go one by one. Let us assume that we shall start with sum, but there is no rule that you should start with only in the sum first then carry. You can start with the carry first then the sum, but usually we will follow left to right approach, left to right, okay, as we write the statement. Clear? Okay, now to come up with a Boolean expression for sum, you need to look at the sum column only. You need to look at sum column only and pick the rows which has 1 as the output. Clear? 1 as the output. So this is in case of min term. If you have focusing on max term, then you have to pick the rows which has 0 as the values. That's it. That's why as I said, if you learn one approach, the other approach is actually the mirror image or the opposite approach of the first one. Clear? Okay. So now we shall focus on min terms only. As I said, you need to pick the rows which has 1 or which will produces 1 as the output. Clear? Now just I am highlighting the rows, okay, which will give 1 as a sum value. Clear? Okay, so how many rows we have here? 4. Why it is 4? Because some column has 4 number of ones. Clear? It is very simple. Clear? So now what we are trying to do? We are trying to write a Boolean expression for sum, right? Okay, I will write here s is equal to, so we shall go to the first value, first value here. Okay, now sum has a value 1 when, see, this is important, when x is 0, y is 0, z is 1. Clear? Since we are using minterm approach, you need to treat 0 as a bar or a negation. So the first combination is x bar, then y value is y bar, x bar, y bar, then z, correct, plus, okay, we shall go to the second term, x bar, y, z bar, okay, x bar, then y, z bar, plus, okay, then what we have to do? Okay, here we should go to the next value, correct? So x is 1, y is 0, z is 0. So x is 1, so x y bar, because y is 0, z bar. Clear? Then plus, okay, last one, x is 1, y is 1, z is 1. Okay, so x is 1, so it will be x, y and z, because all three are 1. Clear? So how many number of terms are there here in this expression? 4 terms. Why it is 4, or why it should be 4 only in this case? Because some column has 4 ones. Clear? So this is another way for you people to cross verify your design. Clear? Okay, now similarly try to get the Boolean expression for carry. So to write a Boolean expression for carry, okay, in minterm form, what you have to do, you need to focus on which column here. Now you need to focus on carry column, and what you have to do is, next step, we need to pick the combinations which has 1 as a output. Clear? So which is that combination? Okay, this is one combination. Okay, this is second combination, this is next combination, and this is the last one. So how many number of terms will be there in the Boolean expression for carry? 4 only, because the carry column has 4 ones. Clear? Okay, now we shall try to write the Boolean expression for carry. So we shall go one by one. Okay, order does not matter, but usually we will follow left to right or top to bottom like this. So the first combination is x is 0. So since x is 0, it should be x bar, then y, then z. Clear? Plus, okay, second combination, x is 1, y is 0, that's why y bar, then z is 1, plus, okay, next combination, x and y are 1, hence it should be x and y, z is 0, z bar, plus, all the last case is all are 1, so it should be x, y, z. So how many number of terms will be there in this expression? 4 only. Clear? So this is what you have to do for designing or while designing a circuit for full ladder. Okay, next what you have to do is, you need to apply Boolean formulas or theorems, so to reduce or to simplify the Boolean expression for sum and carry. Why we have to do simplification? Because if you do simplification, then the circuit diagram will be simpler. If the circuit diagram will be simpler, then it is easy for you to carry out the experiment. Clear? Okay, I will prove this in few minutes. Now we shall try to simplify this expression, sum and carry expression, one by one. First we shall go ahead with the sum one. Okay, now look at this term and this term. Look at this term and this term. Can you pick the common values or terms? Okay, x bar, y bar, z, x bar, y, z bar. So which is the common term here? X bar is the common term. So I will pick x bar as outside, then it will become y bar z plus y. Sorry, actually since I am using paint, I can't able to write properly, but I hope you can understand this. Y z bar plus, and pick the common terms between these two. So which is the common term? I think x is the common term that you can take. X, then y bar z bar plus y z. Clear? Okay. Now this can be written as x bar and y bar z plus y z bar. Okay, this is similar to like x bar z or x bar y plus y x bar. I mean I will make it simple. Make it simple. You have come up with this formula. I think x bar y plus x y bar is given by x exclusive or of exclusive or of y. Correct? So I hope you are familiar with this formula. X bar y plus x y bar is given by x exclusive or of y. In this case, y bar z plus y z bar. Hence, it can be written as y exclusive or. So this is a symbol to represent XOR of z. Clear? Okay. Plus x into. So again, there is a theorem or a formula. Y bar z bar plus yz can be written as y exclusive or of z whole bar. Okay, whole bar. Now I will call this as capital A. Okay, then it will become x bar A plus x A bar. Correct? So I am calling y exclusive of z as A, and here y exclusive of z bar is there, so it will become x bar. Correct? Now can you look at this? X bar A plus x A bar is nothing but x bar y plus x y bar, which is given by x exclusive of y. Hence it can be written as x exclusive or of A. Now in the next step you replace A value. Okay, or substitute value for A. X exclusive or of A is nothing but y exclusive or of z. Okay, then it will become y exclusive or of z. Clear? So this is the simplified Boolean expression for sum, right? Correct? Similarly, now we shall get a simplified expression for carry. Again, you can apply the formulas. Okay, which is a common factor over here? Which is a common factor? I think z is a common factor. You can take z outside, so it will become x bar y plus x y bar. Correct? Then here xy is a common factor. Xy is a common factor. Then this will become z bar plus z. So this is can be written as z x exclusive or of y, because x bar y plus xy bar is nothing but x exclusive of y plus xy ANDed with 1, because z bar plus z is nothing but 1. Correct? Then this can be written as z x exclusive or of y plus xy, because there is a theorem called xy ANDed with 1, or generally any term p ANDed with 1 is p, q ANDed with 1 is q, like that. So and this can be written as xy plus z into x exclusive of y. I think commutative law, you people are familiar with the commutative law. Okay, I mean make it simple, x plus y is equal to y plus x. This is what commutative law says. So this is a simplified expression for carry. So this is what you have to do. Okay, so once you have a simplified expression, then the last step is you need to come up with a final logic diagram for the full ladder circuit. Okay. Now to explain further, just I will erase. Okay, I will erase the previous content. So just I think I'm going slowly. I think if you find any difficulty in understanding the simplification or any other steps, you can contact me. Okay, but it is very easy. but remember, you should know the procedure. You should know the procedure, then only you can able to design the circuit. Clear? We don't want even this. Okay. So what we finally we have now, we have an simplified Boolean expression for sum, correct? For sum and carry. So sum is given by x exclusive or of y exclusive or of z, correct? So this is a simplified expression that we got for sum, and for carry we got xy plus z into, okay, I think this is exclusive or of y, x exclusive or of y, x exclusive or of y. Okay, this is not or, this is exclusive or of y. You can just go back to few seconds back and you can verify that actually it is an x XOR of y. Clear? Okay, so now we are at this point where we have two simplified Boolean expression, one for sum and one for carry. Now we shall learn the final step. So with this simplified Boolean expression, you need to come up with an logic diagram. How to do this? So first, for this you need to go one by one. Again, go for sum first and finish it off sum first. Then you can go ahead with an carry part. So how we can able to get the sum? Okay, move from left to right. Move from left to right. First, what we have to do? We need to perform XOR operation between x and y. So we shall take x and y. What we have to do is we need to perform XOR operation, correct? XOR. Okay, this is an XOR gate. XOR operation between x and y, correct? And this is at this point we will get x ORed with y, correct? I mean this term x ORed with y. To that term, what we have to do? We need to perform XOR operation with one more term called z, right? So I will take one more input called z. Okay, one more input called z, and again what we have to do is we need to perform again XOR operation, correct? XOR operation between x XOR y and z to get sum, correct? So which is given by x exclusive or of y exclusive or of z. Clear? Okay, now we have successfully come up with a logic diagram for sum. Clear? Similarly, now you can go ahead with a carry. To go ahead with a carry, what we have to do? Go step by step. I mean, move from left to right. First, you go ahead with x, y and y term. Where you can get x? Here, right? Here. Okay, this dark point represent connection. You need to take connection from here, and this is a bypass. Okay, x, and you need y. I can take y over here. Okay, y, and I need to perform AND operation, correct? And here I will get xy, here I will get xy, correct? Okay, we completed with xy, and now what we have to do? We need to perform AND operation between z and x exclusive of y. And here can I get x, this is this point, this line, can I get x exclusive of y? Yeah. Okay, take x XOR of y here. Okay, then you need z, right? Then you need z, and this is the line which will provide you the z signal, correct? So I will take z from here. Okay, and what we have to do? We need to perform AND operation. So AND gate, AND operation between x XOR of y and z. Okay, now we are getting this term z ANDed with x XOR of y here. Finally, this term and this term should be odd, right? So we need to take this, bypass here. Okay, take this, bypass here, and take this term. Okay, and you have to perform OR operation. So OR gate should be used to get carry as the output, which is given by xy plus z into, ANDed with x to sur of y, right? So this will be the logic diagram for full adder. Clear? Okay, and you are almost done. Finally, what you have to do is you need to give numbering for input as well as output lines and as well as IC numbers. Clear? So first and foremost, what is this XOR gate, right? So first you need to label the gates with the respective IC numbers. IC numbers are nothing but unique numbers which we already have learned from the previous class videos. So IC number for XOR gate is what? Okay, this is what I said, pin diagrams are very important. So this is an XOR gate and whose IC number is 7486, right? So this is where pin diagram play a role or come into picture. So whose IC number is 7486. So you need to use 7486, and even this is XOR gate whose IC number is 7486. And what is this? Two input bit AND gate, right? What is the pin number? Okay, for IC number for AND gate 7408. 7408. So this is 7408. Again this is AND gate whose IC number is 7408, and this is OR gate, but specifically two input bit OR gate, and whose IC number is 7432, right? So 7432. Okay, so after this, the last step is you need to give the input pin numbers as output pin numbers. Number for input lines and output lines. And how to do this? With the help of a pin diagram. For let us assume that now we shall see that we need to give pin numbers for number for this line, X line, Y line, and the output line of 7486. So to do that, okay, go to the pin diagram of 7486 and see here. Okay, we shall follow this approach. First we shall use this, then second, then third one, fourth one, like this. So this is the first XOR gate, right, whose input numbers are 1 and 2, output you will get at 3. So this will become 1, this will become 2, this will become 3. You need to supply inputs at pin number 1 of 7486, pin number 2 of 7486, and you will get output at pin number 3. Correct? And what about this line? This line will act like an input for the second 7486. Correct? Okay, for the second 7486, what is the input pin number? 4 and 5. Output pin number 6, right? Okay, so with that idea, okay, we will write this as 4, this as 5, and this as 6. So at pin number 6 of 7486, you will get some as a result. Clear? Okay, we completed with 7486 IC. Now we shall do execute the same steps with respect to 7408 IC. So again, for 7408 pin diagram, you need to refer. So we shall follow this approach: first, second, third, and fourth. So for the first two input bit AND gate, according to 7408 IC, input pin numbers are 1 and 2, output pin number is 3. For the second one, 4, 5 are input, 6 is the output. Why I directly jumped into second one? Because look at this logic diagram. We need two input bit AND gates. That's why I referred two AND gates. Clear? Okay. For the first AND gate, what is the input pin number? 1. Output pin number 2. Sorry, input and second input pin number 2. Output pin number 3. And here 4, 5. Output you will get at pin number 6. Correct? Okay. Finally, we left with the 7432 IC. Again, refer the pin diagram of 7432 IC to know the input pin numbers and output pin number. Okay, 1 and 2 are the input pin number of for the first for the first OR gate in 7432 IC, where you will get the output at pin number 3, right? So what we have to do, we need to give this pin number as 1, input second input pin number 2, output you will get at pin number 3. So at pin number 3 of 7432 you will get, or you can expect, carry. So this is the complete circuit diagram for full adder. So now we have finally designed a circuit which will take three inputs, okay, X, Y and Z, and it will produce us two outputs. One is sum and the other one is carry. So previously we looked this complete circuit with a big black box. Okay, have you remembered? We written full ladder in that box. Now we have replaced that black box with a circuit for full ladder using logic gates. Like which logic gates we have used? XOR gate, AND gate and OR gate. Clear? Okay. Now you have to keep this circuit diagram, or you have to use this circuit diagram and use the hardware devices like ICs. Which ICs you have to use here? 7486, 7402, 7432. These three ICs has to be used. Then trainer kit, connecting wise, do the connection according to the logic diagram and verify the truth table. This is very, very important. Truth table of full ladder. Okay, for full ladder. Have you remembered the truth table that we wrote to design? That truth table has to be verified by keeping this circuit diagram. So once again I will repeat what we have to do this. Once we have come up with a circuit diagram like that for full ladder, then you need to verify the respective truth table, okay, of the circuit. So means if you supply 0 0 0 as the input, you should expect 0 0 as the output here, 0 0 as the output, and 0 0 1 as the input, you should expect 1 0 as the output. This is what I was telling. We need to verify the truth table. Clear? Okay. So this completes the theory part or the procedure that we have to use to design a full ladder circuit. Clear? Okay. In the coming videos, what we shall do, we shall keep this circuit diagram with us, and using this circuit diagram we shall do the connections in the trainer kit, and we shall verify the truth table of the full ladder circuit. Okay, before going to that, just connection part I will explain here itself. So the connection is straightforward. Take one input line and connect it to pin number 1 of 7486. Then take another second input, connect it to pin number of 2 of 7486. Then take pin number connection from pin number 3 of 7486, connect it to pin number 4, right? And take one more input and connect it to pin number 5 of 7486, and connect pin number 6 of 7486 to one of the output. Okay. Then you connect from 1 of 7486 to 1 of 7408, 2 of 7486 to 2 of 7408, 3 of 7408 to 2 of 7432, then from 4 of 7486 to 4 of 7408, 5 of 7486 to same line 5 to 5 of 7408, or you can take from Z also, no problem. But the important thing is it should be connected to this particular line. Clear? Okay, then from 6 to 1 of 7432, then finally connected 3 to another output and call it as second output of the circuit. So just at a high level explain how to do the connection, but anyhow we shall see the connection part and implementation part in the next video. So with this I will conclude the session. What we did, just we learned a procedure to design a full ladder circuit. Clear? Okay, in next video or in the coming videos we shall see a practical implementation of this with the help of hardware devices, as I said. So thank you one and all.